Hello everyone. The agenda of today's session to elaborate how containers works for GCP. Basically, I'm creating this video session for GCP only. So understanding is related to the GCP containers. How in GCP provide access to create uh, pods or containers. So basically, what happens in GCP, I already shared in my previous video that in GCP there are two type of licenses. One is pay per pod or pay per node. So we are here to creating pay per node session. In pay per node is a you have rights to create or modify anything on the nodes. So in that Google uh, allows you to create multiple nodes uh, in a Kubernetes environment and manage it. Also is provide the pay per pod. In pay per pod, you can create pod or under the pods you can create the containers. But what is pod? Is a basic thing to know about the pods. Like suppose this is my node, and inside the node we create pods, and inside this pod we creates Kubernetes containers. Okay, so always the containers are located under the pods. So this is how this shows is a this is my container. Okay, so how, if anyone asks you that what is pod in the interview session, or anyone asks what is pods, so how can you elaborate it? Basically, the pods are this orange box is a pod. So pods are the logical boundaries on the containers, or you can say uh, in other words, like containers are created under a logical boundaries that called pod. Okay, so this is my pod. This is the basic understanding. So always whenever we write the YAML code, or through any process we create the pods, inside that pod we create the multiple containers. On the basis of containers, we can say is a single container pod or multi-container pod. Okay, so in this session I will show you how what is the requirement of pod and how we manage it in the background, how it works. So for that, Google provides you a master in the background, and in Google you can create the number of nodes. So by default, Google provides three node cluster to create it in the Google environment. Okay, so here I'm explaining the things on basis of two nodes cluster. So this is my node 1 and node 2. So very first we'll create a container. So suppose if there is no concept in the Kubernetes like pod. So in that case, how we'll use it? We create containers, like this is my container, and this is the container one, and same like this I have created a container here also. So it's a C1, C2, you can naming it anything. So suppose it's a my container C1, and this is my container C2. Okay, and there is no rule related to the pod. Why we uh, use the concept of pods, that I am going to explain you. So this is my container 1 and this is my container 2. So in case we need the connectivity between container 1 and container 2, then what is the requirement is the IP address. So suppose there is a IP address assigned to this container and one IP is assigned to this container, and we have created the network connectivity between these. Okay, this is the network connectivity, and by default, or using the upgrade or any process, my container C2 got crashed. So in that case, we need to create one another container with the same application. So once we create another container, it will definitely it will create with a different IP. So in that case, we need to create the connectivity again. So to avoid this concept, Google has developed the concept of pod. So what is pod? Pod is basically a con like this. This is my pod, and inside that pod, I have created one. Okay, so this is my pod, and inside the pod, I have created the container. So previously, without pod, we have created two containers. In one is in node 1 and another is in node 2, and we have created the connectivity between these two containers. And uh, at that in the case of crash or rebuild the container, it was changing the IP address. So in that case, we need to build the communication again between the containers. So it's not completely automated. To avoid this issue, Google has introduced the pod. So here I have created pod A and pod B, and inside that there are two containers. One is in pod A and one is in pod B. So Nginx and SQL. So Nginx is a web server, and this web server is fetching data from the SQL. So there is a connectivity between them. So what happens in this case? So now there is no connectivity between the pods containers. It's a between the pods. So here we'll create the connectivity from pod A to pod B, and the IP will be assigned to both pods. So pod A has a IP 10.10.1.2 and pod B has a IP 10.10.1.3. Okay. So in that case, if now the container will crash. In that case, containers will rebuild again, but we no need to rebuild the network connectivity because the pod is still there. Also, remember one thing, once we create any container inside the pod, by default, it creates a container with the name of pause. Okay, this container with the name of pause will be created in both pod. Okay, and what is the use of this pod will take the namespace of containers which is created inside the pod A or pod B anywhere. So it holds the namespace, like suppose is a namespace and IP of the pod also in the pause. So once the traffic will come from the pod B to pod A, it will come to the IP address and then it connect with the pause, and that pause named is a container will redirect the traffic to the Nginx container, and we can access the application. So is a namespace of suppose ABC is a namespace. Okay, so if interviewer will ask a question like by default how many pods created, or while we create a container inside a pod, how many containers will create there. So it's a create two containers. One is the container which you are going to create, or second one is the pause. And the use of pod container is to take the namespace, and it will uh, uh, store all the namespaces of the container. Suppose it's a multi container pod. So in that case, if you have another container there, so the namespace of that container also is stored in the pause. Okay, suppose this is my another container is a container 2, we can say. So the namespace for this container is also stored in the pause container. Okay, and same will be applicable for pod B. So this pause will be responsible to store the namespaces of each container which is stored or created in that pod. Okay, now we have rectified the things. While container will destroy or will recreate a container, it will not change the network connectivity, because connectivity is through the pod. But suppose in case of pod get crashed, or we will recreate the pod, in that case, there is another things which is we need to create inside the node 1 or node 2, that will make the things available, or that will not impact your network connectivity. Okay, so these things are like deployment and services. So now in case that pod A is get crashed or pod B get crashed and we recreate that pause, to avoid these things, if there is a deployment we need to create on the node, that is, can say is a deployment. So a deployment will need to create in both node, or if you have multiple nodes, node A, node B, node C, node D, then in all nodes you need to create deployment. Okay, control. So the same thing we need to create on node 2, and now the connectivity will not be here. We'll remove this. Okay, so now what is the use of pause container? Pause container is responsible to add containers namespace in the table. All containers namespace is a multi container pod. Then all containers namespace will be stored in pause container. Also, is a no IP will is assigned to the container. IP assigned to the pod by is a as per the technology Google developed. The IP will be assigned to the pod. Okay, that's why we if the container get crashed or recreate, it not affect the network. Okay, because the IP is assigned to your pod. Okay, now we'll come to the deployment. So suppose we are running a command is a kubectl run web server like nginx. So I'm running a command using the kubectl is a like kubectl run web server. Is a web server is the name of the uh, container, and image, which image I'm going to use is the image nginx. Okay, so in that case what will happen? Nginx will be created here, pause will create, and here is a image will use as a SQL, and SQL image will create. Okay, so I shown you is a if the container IP will bind, then in the case of container get crash, we need to create the network connectivity again. That's why it's happened with the I shown you with the pod. Like if the connectivity will stable with the pod ID, and in case of pod get crashed, then again we have to come to the manual things. But we are going to automate these things, so that's why we need to create a deployment. And deployment is basically connected with the container, or is a pod A, or this will be connected with the pod B with the IP address. And now the deployment is responsible to make the redundancy of the pod. Same like pod is responsible to make the redundancy of the containers. So if container get crossed, pod will recreate it, and there is no impact on the network connectivity or between the connectivity. That's thing in deployment. If pod get crashed, so deployment will take care of that, and it will make the redundancy of the pods. Okay, and in case is not there, so uh, the technology says that on the top of that you need to create a service over here. Okay, this is my service, and in the node B also will create a service, and now the IP will assign to this service. Okay, so first I will tell you how many type of services available here. So this is my service, and this is also a service in another node. Okay, and the IP address will assign here, but first let you know about the services. That there are three type of services. Okay, the first type of the service is the cluster IP, and second type is a node port, and the load balancer is the third type. So here suppose in services I use the cluster IP. So once I use the cluster IP as a service, it will assign a IP address to this one. So the container I is a cluster IP. So cluster range IP will be assigned. Like my in my side is a 1020.1.3 or dot 2. Okay, dot 1 dot 2, and I will change the font size. Is I will make it 12 here, and same thing in another side it will create with the 10.20.1.3, and again it will be the so IP will be assigned to the service, and here I'm using cluster service. Okay, so now while you use the cluster service as a service here and will deploy the service here, then the communication will happen from pod A to the service, and from service to another service, and then it's come to pod. Like suppose to segregate that I am keeping service A, and here is a service B, but in the both side is a services cluster type. Okay, so the traffic will come from the pod to service A, and from service A to service B, and then again to pod B. Okay, so now the IP of service A and service B will be bind, and this will to make the redundancy of your pod, your deployment, and all the things which is under the this hierarchy or this hierarchy. Okay, and in this case, once we have created this or services allowed, and now we want to access this nginx pod or nginx container from the internet. Suppose this is my internet, and from here this is me, and I want to access this nginx service or nginx container or the application which is in this container. So would I be able to access it? No, because this service will here for the internal communication inside the cloud only, not from the internet. Okay, so make this available from the internet. What we'll do, will take the service as a node port. So once we deploy this as a node port service, it will provide you the IP, bind the IP, node IP with the port number, any specific port number, and we can access this from the internet. So there is a difference. If we are taking the service as a cluster IP, then in that case, the cluster IP service will provide you only the cluster IP. But if you will take the service as a node port, it will provide the cluster IP here, as well as it will bind a port with your node. So once you access from the internet like HTTPS 192.168.1.3 with the port number, it will goes to the service, and service will redirect it to the pod, and pod will open this nginx application for you here. And this nginx will try to access this SQL. In that case, pod will send it to the service, and service will send it to another node service, and it will come to the pod, and pod will send the data to the nginx container. So that's why uh, in the beginning of this video I have tell about the multi-node, uh, multi-container pod or single container. So in case if your applications are dependent to each other, so in that case you can do that. If the nginx is dependent on SQL server, in that case you can put this SQL server here only in the same pod. So in that case it will not going again anywhere to fetch the data from the database container. It will directly fetch it from here and redirect it to your console. Or same way, if you are creating any container service here, like your application, your database, then again it will map with the another port. Here you need to map with the like port number. Suppose you are doing this with the port number 8080. So once from here you will access the port number 8080 with the IP range, then it will provide you this application. Okay, so this is the architecture which is working behind the clusters. Okay, suppose this is my app and is a my database DB, and now user can is a thing. User can access the both containerized application from the internet using the port node port service. So is a node port service is a deployment, and the containers is your pod, and in the master server or master node is a there are four services which I already covered in my previous video. So for deployment and services I will create one more video for you guys, and my next video I will deploy a pod container with the ports service. So for that also as like my previous videos, you need to write the YAML code and call this that YAML code and to the it you need to create the containers. And for that, in my previous video I used a command kubectl create hyphen f and your YAML file name. And to delete that container is the same command kubectl delete hyphen f YAML file name. Okay, so if in case of any confusion, you can put your comment in the comment box and ask me questions, so I will reply that question. And if anything I need to cover in my video as per your question, I will include that in my next videos. And I will create a separate videos on the basis of your questions and put all the answer in a single video. That is my future planning for the this Kubernetes section. Okay, thanks. Bye. In case of anything, you can put your comment in the comment box. Thanks for watching.